Welcome to our Notes on Conics sections and hyperbolas. Students will be able to create the standard form equation of a hyperbola, identifying properties such as the center, foci, vertices, and asymptotes after reading a guided text. A hyperbola is a set of all points in the plane whose distances from two fixed points in the plane have a constant difference. The fixed points are the foci of the hyperbola. The line through the foci is called the focal axis. The point midway between the foci is called the center. The 2 points where the hyperbola intersects the focal axis are the vertices of the hyperbola. The line segment lying on the vertices is the transverse axis of the hyperbola. The length of the semi-transverse axis A is the distance from the center to the vertices. So here is the transverse axis of this hyperbola, and here is the transverse axis of this hyperbola. Half of that distance is the semi-transverse axis. So I will go ahead and highlight those green so that we know. So thus far, everything that's highlighted in green is all lying in the same vicinity. So the foci are the following, and all of this lies on the focal axis. Now, the line segment that is perpendicular to the focal axis connects the co-vertices and has the center of the hyperbola as its midpoint is called the conjugate axis. Okay, so the conjugate axis, I went ahead and labeled it on the graphs. Half of the length of the conjugate axis is the semi-conjugate axis B. It is often not represented graphically, so usually we won't have to plot the co-vertices, but we can find it if we use the Pythagorean relation. We'll need both the semi-transverse axis A and the semi-conjugate axis B in order to write our equation. C is the Pythagorean relation representing the distance from the center to the foci. So here's a useful table that we're going to refer to when creating our standard form equation of the hyperbola. The difference between the ellipse standard form and the hyperbola standard form is that here I have a minus instead of a plus. So the ellipse has the plus, but the hyperbola has a minus. So the order actually matters here. So if our hyperbola faces left and right, then we have to write x minus h squared over a squared. And then if the hyperbola opens up or down, we have to write y minus k squared over a squared. So I like to think of it as x is left and right, direction, and y is up and down direction. Our Pythagorean relation is the Pythagorean theorem that we are familiar with. Unlike the ellipse, it was a squared minus b squared, but here in the hyperbola is a squared plus b squared. And our asymptotes will be given by this. By these two equations, but I will show you how you can remember that graphically. So let's work on an example. Here we have a graph of a hyperbola that opens left and right. We're going to find some characteristics like the center, the vertices, etc. So based on what we have the hyperbola, we have the foci. So now I think one of the things we can find easily are the vertices. So we have the vertices here and here, so that's -4, 2, and 2, 2. Also, one thing that we know because it's given to us are the foci. So they are located at -6, 2 and 4, 2. So now let's find the center. The center is going to be midway between the two vertices here. So let's figure out how long the transverse axis is. The transverse axis is the length from one vertex to the next. So I will go ahead and just label vertex 1 and vertex 2. So the distance between V1 and V2 is going to be our transverse axis. Halfway will be our semi-transverse axis, which we're going to need to know. That's going to be our A value. So if I count 1, 2, 3, 4, 5, 6, that means The transverse axis has a length of 6, which means the semi-transverse axis must have a length of 3. So if I move 3 units in, I will be at my center. I'll call it a capital C for center. That's going to be very helpful for us. Just for good measure, I'm just going to go ahead and label on the graph what the A value is. So our A value is here, and that's a distance of 3. So now let's find the C value. The C value is going to be the distance from your center to one of the foci. So here's my focal point 1, and here's my second focal point. I'm going to count the distance from the center to the focal point. So this will be our C value, our little c value. That distance is 5. We're going to need to know that in order to find our semi-conjugate axis. So recall the fact that we can't see what the B value is graphically. We have to use the Pythagorean relationship in order to do that. And the Pythagorean relationship is just the Pythagorean theorem that we're used to. C squared equals A squared plus B squared. I'm going to go ahead and solve for B squared. That will mean that this is C squared minus A squared. I'm going to go ahead and plug information in. I know that C is 5, so C squared is 25, and A is 3, and A squared is 9. So that means my B squared equals 16, therefore B equals 4. I'm going to just go ahead and copy that over. So I had to calculate the B value. So even though B is usually not represented graphically, I'm actually going to draw them in, and you'll see why in a moment. So if I start at my center and I move out 4 units, I'll be at 1, 2, 3, 4. My co-vertex 1 is here, and then I'm going to move out 4 the other way. 1, 2, 3, 4. My second co-vertex is here. Right, so I just realized we never actually wrote the point for our center. Our center is -1, 2. And from there, what I'm going to do is I'm going to find the slope between the vertex 1 and the co-vertex 1. So I'm going to use highlighter to kind of show you what I'm doing next. I will use blue. Doesn't matter which one you use, but I'm going to find the slope of that line right there. So I needed to have moved up 1, 2, 3, 4, and I needed to have moved right 3 units. Well, that is going to be the slope of one of our asymptotes. And our asymptotes are going to go through the center. So I'm going to start at the center, and I'm going to produce that same slope. I'm going to move up 4, right 3, up 4, right 3. I'm also going to move down 4, left 3. So I'd be right here, down 4, left 3. 1, 2, 3, 4, 1, 2, 3. And I'm going to go ahead and draw a line through that. So I went ahead and drew my line. I'm just going to highlight this one blue so that you know it has the same slope as the other blue line that we have. I'm going to label this Y1. And now I'm going to find my second slope. And my second slope, I'll use a different color here. So why not pink? I need to find the slope between vertex 1 and co-vertex 2, because that is going to have the same slope as my other asymptote. So, and it will go through the center as well. So in order to get here, that means I moved down 4, right 3. So I'm going to start at the center, I'm going to move down 4, and I'm going to go right 3. I'll end up here, down 4, right 3. I'm going to do the same thing in the opposite direction. I'm going to go up 4, left 3. And I'll do it again, up 4, left 3. And I'm going to go ahead and draw my line through those points. So I went ahead and drew my dashed lines through all these points I just drew. And again, I will take my highlighter just to kind of show that this asymptote will have the same slope as the slope between vertex 1 and co-vertex 2. So I can always find it that way instead of memorizing some formula. Now I'm going to go back to the table, and in fact I'm going to rearrange this a little bit to make it a little bit simpler for us. If we're going to stick true to the point slope form, I'm going to write it like so. So this should be fixed on your paper, so you shouldn't have to do this one. But really, we're going to have the y minus k, x minus h kind of echoing throughout our conic sections here. The only difference is that the way it's written on this right now is we added k to both sides, but I don't think that's necessary. So I think if we keep it truly as point slope form, is y minus k equals plus or minus b over a times x minus h, or y minus k equals plus or minus a over b times x minus h. Remember, I'm going to go ahead and fix that on your paper, so you shouldn't have to do that. But I'm going to use the point slope form in order to write the equations of my asymptotes. So the equation of our blue line, actually I'm going to call this one y2 just to kind of keep with the same essence of labeling. I know we're getting kind of messy here, but the equation of our y1, here I'll just call it y1. I'm going to use the center as the point for my point slope form. So the k value here is 2, okay, equals, and our slope here was to go up 4, right 3, so this is going to be positive 4/3 times x minus h, so minus negative 1, so x plus 1. And that's the equation for our blue line. Here, I'll go ahead and label it blue. That's our blue line. Now for our pink line, we're still going to go through the center, so I'm going to use the same one. So y minus 2 equals, this time it's negative 4/3 times x plus 1. The last thing to do is to now write the standard form equation of our hyperbola. So because it opens left and right, I know I'm going to start with x minus h. So x minus h is going to be x plus 1 squared, and I know that's going to be over my a squared. A was 3, so a squared is 9. Then I will have minus, I'm going to have y minus k, so y minus 2 squared over my b squared. B squared was 16 equals 1, and there is our standard form equation of this hyperbola. Why don't you try the second example?